Hey everyone, we're going to go ahead and continue the last video, which was talking about parametric equations and their graphs. And when this one, we just want to look at a few other ways of what's called eliminating the parameter. Last time we went through this one right here, number one, where this was the first example where you can solve an equation for t and then plug it in, and that kind of eliminates the parameter. You only have x's and y's left, and then solve it for an equation you recognize. This time we'll be going through a couple of these, 2 and 3. And I'm going to actually start with 3, and then we'll come back to number 2. So let's do this example 2. It's right here. Sketch the curve including orientation, and then find a rectangular equation by eliminating the parameter. So sketching the curve, we kind of went through this last time using Desmos. So I'm going to do that again. X is 2 cosine t, y is 3 sine t, right? And this time t is only going between 0 and pi, right? So t is only between 0 and pi. So we'll go ahead and put those into Desmos. And in this one I got 2, right, cosine t. So we'll say cosine t. You do have to use t for these parametric equations. And then don't add the slider when it prompts you on that one. And then we wanted 3 sine t. So this is 3 sine t. And that will be... right now it's just going 0 to 1, so that's kind of the default. You'll always see the t just go 0 to 1 kind of when you first enter it. This one we did want to go 0 to pi, so I'm going to go ahead and type in pi right there. And now you can see, right, we got kind of what looks like this arch. This I think is actually the top half of an ellipse, so we'll maybe see that a little bit later when we're eliminating the parameter. For now, we also want to include the orientation, right, in our sketch. So we'll sketch this in the other thing in a minute. But I do want to include the orientation. So I'm going to go ahead and try just duplicating this and changing these t's to a's. So this can sometimes be a shortcut, duplicating if you click the gear and then just duplicate. Then you can, rather than having to retype, especially if they're really long equations, it'll just recopy it, and then I'll just change all your t's to something like a, and then now I can change my a to be whatever values I want them to be. So we are going from 0 to pi. So again, put in here 0 to pi, and you can just play that, pause it a little bit. So we're starting, let me go and change this one to green. And if you hit the drag, that means you can drag the point, but it'll also make it a little more visible, right, if you have a hard time seeing where those things are. So I'm going to do that for the video. But now this A, right, you can drag from 0 and see which way it goes as you trace that out. So from 0 to pi, we're starting over there on the right and then going counterclockwise, kind of the usual direction as we get to that left side. That's usually going to be the case if you have a cosine and a sine for the x and y. That's our usual way we trace stuff out. So that's what we'll do for that one. So I'm going to go ahead and just note that, right, we're starting on the right, going over to the left, and we'll make a sketch in this one over here. So again, I'll just use this little graph down here. So we're going, let's see which way we're going, 1, 2. So 1, 2, and then over here as well, right? 1, 2, and we're going up 3, 2. That's kind of messed up right there. All right, let's try this again. We got 1, Need a much smaller eraser, I believe. Try to erase that. Okay. Sorry about that. 1, 2, 3. So up like that. So we are going right this way. This is going to be our curve, and we'll go and put some arrows in there. Right as we trace that around, we're going to start here, right, with t as 0. At that point, 2, 0, and we'll end over here at -2, 0 when t equals pi. So that is my curve, right? And then we want to, right, eliminate the parameter. So this is one where we're going to use a technique that is like this number 3. So I'm going to think of this as x is 2 cosine t. I can get rid of the 2, right, if I divide both sides by 2. Y is 3 sine t. You can get rid of the 3 if I divide both sides by 3. And I need an equation that relates both sine and cosine. So that's kind of this idea of using a separate identity, right? Something that relates sine and cosine. Well, I know that sine squared, and usually we put thetas, we're using t, so I'll put t on this one. So sine squared plus cosine squared is 1. And now I can go and replace that sine and cosine with what I had up here. So what I had up here was, again, if I divide both sides by 2, that x over 2 is cosine t. And if I divide both sides by 3, that y over 3 is sine t. Now both that sine and cosine are going to get squared, so we'll go ahead and replace that sine with y over 3. That's going to get squared. We'll replace the cosine with this x over 2, and that's also going to get squared. Over 2 also gets squared, and then that equals 1. All right. And this may not be the usual format you're used to for ellipses, right? We can go and maybe square both sides, put the x first. So we would say maybe this is x squared over 4 plus y squared over 9 equals 1, right? And that is the usual kind of standard form of that conic, right, the ellipse. We're only using the top half, so I'm also going to put a little restriction over here. All our y's need to be bigger than or equal to 0, right? So we're not doing the whole ellipse, just the top half. So this would be what they call finding the rectangular equation and eliminating the parameter. So that parameter t is no longer in there, just the x's and y's. So that's kind of this number 3, using a separate identity. In this case, that Pythagorean identity, sine squared plus cos squared is always 1. And then we can replace that sine and that cosine with stuff in terms of x and y, and that helps us write that equation just in terms of x and y. The last one that we'll do is sort of using this number 2 that's right here, and we go ahead and change, maybe we'll use purple on this one. So number 2 right here. Solve one equation for something larger than t, and then replace that in the other equation. So we'll go ahead and do one of those next. So we're going to do the same thing here on number 4. We got x is cosine t, y is cosine 2t. Sketch the curve, include orientation. And I'm going to go ahead and do part B first, and then we'll sketch afterward. So find a rectangular equation, right, by eliminating the parameter. Let's do that part first. So we got x is cosine t, y is cosine 2t. I need to find something I can replace, or some identity. There's maybe this cosine 2t, right, double angle, has something useful I can use. So cosine 2t, we know, is the same thing as, there's a couple options, right? So double angle for cosine has few options. Cosine squared minus sine squared, it's one of them. And then you can double one of them, change the other one to 1. So like a 2 cosine squared t minus 1. And essentially what we're doing is replacing that sine squared with one of its Pythagorean equivalents and then just simplifying. But these are kind of useful to know right off the top of your head. And then the last one is, again, reverse, right? The first one changes to a 1, then the second one has a 2 in front. So cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Are any of those useful for us? Well, I think the second one is going to be the most useful because our x is a cosine, and we don't have any sines sitting around that will help us replace anything. So I'm going to go ahead and use that first, or that second one that's right there. So I'm going to go ahead and erase these guys. So cosine 2t is that 2 cosine squared minus 1. And we can go ahead on this one. So there's a couple ways you can think about it. You could treat this as like that number 3 case we did last time, where cosine 2t is the y, so I can just replace that with y. 2 cosine squared, I can replace that cosine with an x, all right, so 2 times x squared, and then minus 1. So this is kind of that useful identity that we put it in. Another way you can think about it is if you had, say, something like this, where you had y is cosine 2t, not 2 in front, just cosine 2t. Cosine 2t, and then I wrote out the identity, right, which is 2 cosine squared t minus 1, and then I replace that cosine, right, with the x, right? So now we replace y is 2, and that x gets squared, right, minus 1. So either way, right, you can kind of go through it the same, but this is more like what you'll see in that kind of number 2 is I get y in terms of something bigger than t, right? I don't have to go all the way down to t equals, and just replace that bigger something with the x, or something related to the x. Sometimes you'll see these also with like e to the t's or natural logs, or if I have both of those, right, in both equations, then sometimes you just solve for that bigger piece and then replace it in the other one. Kind of like we did here. We just replace the entire cosine with the x rather than having to try to use inverses or anything like that. So regardless, right, we have this y is 2 x squared minus 1. So 2x squared minus 1, that is a parabola. All right, so I should expect a parabola. There may be a restriction, right? Cosines only go between -1 and 1, so more likely than not, there's going to be some sort of restriction that we want to involve with these guys. Because the x's, right, are cosine of t's, really the x should stay between -1 and 1. So I could probably go ahead and just put that in right now, and then we'll go and confirm this, right, with our graph, right? So this is kind of what I'm expecting out of my graph. Let's go ahead and sketch the curve, include the orientation. Again, right, I could probably sketch that by hand if I wanted, just going off that rectangular equation, but we'll go ahead and go back to Desmos, see what we get with that. So I'm going to go ahead and hide these guys, and this one will say, all right, include the parentheses, so we got our cosine t, all right, so functions cosine t, and then we got our cosine 2t, right, was our cosine 2t was our y. And then we're going, right, t is not between 0 and 1. T is as far as you want. There was no restriction. So we could go anywhere from like I said, I'll put in like maybe -100 all the way out to like 100, something like that. So really it's negative infinity to infinity, but we can't put infinities in, so we'll just put in big numbers. And we are only going around that part of the parabola right there. Again, if I want to see the orientation, right, I'll duplicate that, put in an A in place of a T. Right, so put in this value of A right there, and A right there. And then let's go ahead and make that a different color. Let's use purple and we'll make it a little bit bigger. And now we'll go ahead and start, right? Our A's also have to change. Let's say we'll just go 0 to, like, again, 5. It's probably fine. We might change it because we know we do have a larger range in there, but it's just a good place to start. So right there is where your T or your A is 0. And then we'll go ahead and play that. So it goes up and then back. And let's actually, make this a little bit larger number. That's right there. All right, so I went ahead and changed that A to 20. And we'll go ahead and see where that goes. So you'll notice this is going like back and forth along this guy. And I'm going to move one direction in time, not both. So when I say here's 0, and it's going back and forth, right? And that's kind of expected with our cosine, right? Our cosine goes between 1 and -1, 1 and -1, back and forth, back and forth. So that's not entirely unexpected, but we do want to make sure when we're sketching that that's the only part of the parabola that we trace out. So we're going to start down here at -1, right? Go up, and when we get to 1, this point up here at 2, and just go back and forth on that. So that's what we'll include in our sketch. So we're going to go ahead and say go -1, and then when we're at 1, we're going up 2. Actually, let me check that. If we are at 1, actually that should just go up to 1 right there. So this is our parabola. Right, it looks something like that. That's a very rough sketch. And our orientation, right, goes back and forth. So we actually include arrows that are both directions. So both directional arrows right there. And I'm going to make that a little bit bigger. It's really bad. So we're going to make our scale a little bit more on here. So these are my dots I'm trying to hit, and I can tell it's like a nightmare parabola right there. But anyway, you get the idea, I hope. And then we'll include the arrows, right? They go back and forth on those guys, or just to indicate that we are moving backwards and forwards, not just one direction. But you don't want to include the whole parabola, just those pieces right there. And that restriction, right, x is between -1 and 1. That'll kind of do it for us on this video. Next time we will take a look at, given a graph, how to find the equation. This is a little bit trickier, but things like this where there's the description of a graph and then you want to try to figure out what equation goes with it. So that gets, like I said, just a little more complicated. The main thing with those is start off with a good picture. So anyway, that'll be next time, and we'll see you on the next one.